Good morning, everyone. How is everyone doing this morning? All good? Had a good conference so far, last day. A lot of knowledge to sip in and just enjoy this last day of great topics. Before we get started, I really love NDC and appreciate the organizers. Could we give a round of applause to all the organizers? Excellent. That's going to confuse everyone else outside as well. They thought this talk was very short. We're going to be talking about what's new in .NET 8 and C# 12. There's quite a lot happening in both .NET with the entire ecosystem. In Visual Studio, in C# as a programming language, can be pretty hard to keep track of exactly what's going on. I'm Filip Ekberg. I've been here a couple of times before. If it's your first time seeing one of my talks, feel free to send me an email afterwards and ask any questions that you might have. I've been telling people for years to send me emails, but no one ever sent me any questions. You know why? I forgot to put my email on the slide. So I thought I was super clear with everything I covered, but if you have any questions afterwards, feel free to send me an email or just grab me in the hallways. So we're going to be talking about everything about C# and .NET and how this language and how .NET as a runtime, framework, and all of that has changed, and then why you would like to upgrade to the latest version of .NET. Is anyone here using .NET 8? Oh, about half. Is anyone still using .NET Framework? Oh, about as many. It's time to upgrade. I know that sounds easier than it is. I have a lot of customers that work in .NET Framework and trying to get a reason to jump over to the new .NET. I still want to call it a framework, but that gets very confusing. But there's a lot of good reasons as to why you want to jump over to .NET, and especially with .NET 8. We're going to try and cover some things. This is a tag cloud of all the features added to C#, and we're going to cover some of the new ones that I'm not listing here. So we'll start off with .NET 8, which is the latest version of .NET. And what's changed with this? There's helpers to work with dates and times. There's improvements to System.Text.Json. There's a lot of performance improvements. There's many things that we're going to be covering here today. What's interesting with .NET is that they follow this very specific release cycle. So every year there's a new version. In November, they always release a new version during .NET Conf. At least that's been the case for the past few years. So now in November last year, they released .NET 8, which is now the latest version, and it's the long-time support version, which means that it's going to have support for up to 36 months, which is quite a long time. If you're on .NET 7, anyone on .NET 7 still? You know what? Support for .NET 7 ends in May this year. So it's a good time to actually upgrade. Doesn't mean it's not going to work anymore. It just means that there's not going to be any more support fixes for it or any updates to it. So you might as well just upgrade. And the idea is that it should be super simple to go from .NET 5, 6, 7 up to the new version. You just toggle a switch in your project file and rebuild the application and everything works. Does that ever happen? Probably not. Microsoft has a really good track record of being backwards compatible. And that's true for most of the types of applications. But if you're doing, for example, .NET MAUI or Blazor or other UI-type applications, then it's not really true. It gets a little bit more tricky, and especially with dependencies on other projects as well. But I guess the idea is always to build anything with .NET, and that's even more true with the latest version of .NET. Finally, there's, I would say, complete support for building cross-platform mobile apps. That story is a totally different talk, but now we can use MAUI to build applications for .NET, for iOS, Android, and Mac OS and Windows, and do that with one platform. So the idea is still to be able to build anything with .NET. Even though this was initially the idea with .NET Framework, if anyone in here is a .NET developer and started out with .NET 1, for example, .NET Framework 1, you know that the idea was that if you have a platform that has a runtime for .NET, it should be able to run your C# and VB applications. But Microsoft didn't build a runtime for any other platforms. But now they do, and now you can run the .NET apps for Linux, Mac OS, and Windows, and so forth. So with that being said, of course we want to be looking at what's new in .NET 8. There's a lot of performance improvements. I'm going to be talking a lot about how they do this internally, what tips and tricks you can use to do the same in your applications. While I've said performance, 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 I'm not going to jump around like Steve Ballmer, screaming that here on stage, but it is really an important aspect of .NET. If you were to upgrade from .NET 5 to .NET 8, you've had a tremendous amount of performance fixes, which is also including less allocations, optimized code paths, and everything's just going to run faster. And they've done this because they've introduced improvements in the language as well as in the runtime. They gradually add this to their internal components to make everything faster. So the idea is that if you just toggle over to .NET 8, rebuild the application, you will make use of all those new performance improvements. They've also introduced what's known as a time abstraction, which is making testing better for if you're using dates and times, for example. We'll look at that in just a moment. A lot of improvements in System.Text.Json. Is anyone using Newtonsoft.Json or JSON.NET? Oh, wow. Almost all of you are using JSON.NET. Is anyone using System.Text.Json? About as many. That's great. The idea was never for System.Text.Json to replace Newtonsoft.Json. Even though Microsoft hired the guy who built Newtonsoft.Json, it's still being maintained. But it's good to have an out-of-the-box experience in .NET that focuses on performance. It's not meant to be exactly the same as Newtonsoft.Json. Newtonsoft.Json works with JSON documents that aren't super well formatted. It is very forgiving for the JSON data you pass into it, which also means that it's not as performant as it could be. So the built-in support now for JSON is focusing on making everything faster when serializing and deserializing data. There's also improvements to ASP.NET Core, which includes, again, performance improvements. It also includes support for Blazor applications and changing how we build full-stack web applications. And of course, we have .NET MAUI. Now, if you want to use all of this and we want to build a .NET application using the latest version of C# or the latest version of Visual Studio, or if you're working on an older project and want to figure out, can I do this in my project? Knowing exactly which version goes with which version of C# can be a little bit tricky. So if you want to use .NET 8, you can use C# 12. If you want to use C# 11, you could only do that on .NET 7 and so forth. So there's they try to tie the language into the runtime or the release of .NET. The reason for this is because they can then focus on building fixes for the language or improvements. For example, in .NET 9, which we're really not going to cover here today, but they're investigating how to rewrite everything for async and await. How could they build support in the runtime for async and await? Instead of having the TPL fake a state machine and build all of that using the compiler, why wouldn't they be able to do that in the runtime instead? It's a really interesting GitHub issue discussing how they could approach this. But that wouldn't work if you were to then use C# 15 or whatever they're going to do that in with an older version of .NET, because there's not runtime support. So I had a client that worked in .NET Framework 4.8, and they wanted to reduce the amount of repetitive code, meaning that they would like to use primary constructors and use other types of language features in C# that allows you to write cleaner and better code. But they couldn't just upgrade to a latest version of .NET, but what you can actually do, which is unsupported, is to go into the project file and set the lang version to 12, which means that if you stay away from runtime required language features, you can use C# 12 with .NET Framework 2.0. Pretty cool. But it's unsupported from Microsoft, so you do that on your own. But I did mention that once we've decided that we're going to use the latest version of Visual Studio, we're going to use .NET 8, we're going to use C# 12, the idea is that we're now going to go from something that's, oh, no one's here from Microsoft, because calling the older versions of .NET rusty is probably not very popular. But they've done a lot of improvements. They've polished all the internal pieces. They've gone from this older Kong that's a little bit older and made it a little bit better. Run faster, be more in line with what you'd expect in 2024, 2025, right? So it's a lot more performance. And the reason that I'm talking about this is because they build this on top of language features and runtime support that has been added in older versions as well. So let's say that they introduced a language feature in C# 10. It takes a little while to adopt that. And across Microsoft, which is a pretty big company, it takes a little bit of time to educate the developers of the different pieces or the different components how to use this more effectively. And what they do quite a lot is to use a couple of principles or concepts to make this a lot more performant. They're using a type called a span, which is a new type in .NET. Not in .NET 8, it was released a couple of versions ago, I believe .NET 6. And this span type allows you to look at any type of memory. You can represent managed on memory, memory allocated on the stack, on the heap, whatever. You have this one generic type that can reference any type of memory. And all the operations that you do on this stack or array of data is super fast. It doesn't do any extra allocations. It doesn't have to do a lot of extra operations when you're copying or slicing things. This, together with a language feature called ranges, both equal performance. So a range is a way for us to provide a syntax for accessing one element or an array of different elements, or a range of elements. If you've done Python, for example, you've probably seen this before. I can skip the two first elements and give me the rest of the list. I can get everything except the last element in the list, or I can get the two last elements of my list. It's a very nice syntax to be able to access things where I know exactly where they are. I can also use this if I know the index of a certain element and slice it off. And this, together with the spans, is a way for me to write zero-allocation code. So let's imagine that I'm getting a payload here. We could say that this is coming in from a Bluetooth beacon or whatever. I do a bit of work with hardware as well, so I get byte arrays like this here. Now, this byte array, I want to look at this as a span instead. So on the second line, I'm taking this byte array and I'm implicitly converting that into a span of bytes, which means that on the last line, when I want to select a subset, which means give me the two last bytes, this doesn't have to do any extra allocations. The alternative in older versions would have been to, at least personally, I would probably use link to say, hey, I want to skip until this element and take these two, or write some code that's much less performant. Now, I have another example of this here to write zero-allocation code, and that's to, for example, say that I'm declaring a UTF-8 string literal, which is my name, a C#11 feature that allows me to use UTF-8 strings directly in my language as constant strings. Someone's probably asking why you wouldn't want to do that. It's because everything on the web is UTF-8, and everything in C# and .NET is by default UTF-16. Making the conversion between UTF-8 and UTF-16 is a little bit time-consuming, like a couple of CPU cycles, requires some extra memory allocations. So being able to define this using a UTF-8 string literal is a lot more performant, if I know the data, that is. So what I'm doing here is I'm declaring a read-only span, which is pointing to this UTF-8 string literal in memory. I'm locating the space in the middle, and then slicing everything off from the start until the first space, and then I'm grabbing my second name as well and putting that in a second span. This here doesn't do any extra memory allocations in terms of working with that array of data. Of course, it does 2 allocations or 3 allocations on the stack to put the references to the different variables, but it doesn't do any more allocations than that. Traditionally, you'd have to copy the array over and do a lot of extra CPU cycles to do that. And for mobile, for example, extra CPU cycles means draining extra battery. Again, being more performant in terms of both memory, battery-wise, CPU cycles. We're going to save the environment by using .NET 8. I'm kidding. So, what also comes hand in hand with this is native AOT, which is also a concept that they've worked on quite a lot for quite some time. Native AOT has been a concept available. If you've done Xamarin, for example, you've natively compiled your iOS applications. You take your .NET application and you compile that, and then it's natively executed on the platform. This is now possible for any type of .NET application. You can take an ASP.NET Core application and natively compile that for a Mac, or natively compile it for a Linux machine. And doing this will reduce the startup time. It will reduce the time it takes to do certain executions or all the operations, because everything executes natively. You can also bundle the parts of the runtime that are necessary to execute the application if you so like to. So I can say I have my Windows application written in WPF, natively compile that for Windows, and bundle the pieces with the runtime that are necessary to execute this. Sounds like it's going to be quite a huge binary, but in fact, comparing .NET 6 with .NET 8, for example, they've reduced that from, let's say, 100 megs to 20 megs. So the binary sizes are much smaller. Not that it matters here. We have a lot of disk space and fast internet, so it doesn't matter too much. But doing this is going to make the applications a little bit faster. And it's good for things like mobile applications. They've also done some improvements internally in the library by introducing what's known as a performance-focused type. Now, they've introduced a new collection or a new namespace called System.Collections.Frozen. Has nothing to do with Disney. So when you take a dictionary, you fill that with, let's say, millions of records, and you want to be able to very quickly execute that. You know you've set up your dictionary with keys and values, and you know that it's no longer going to change. If you change that to be a frozen dictionary, it's then going to be optimized for accessing and reading elements, which is, again, a lot more performant. So the idea is that you take your source and you convert that into something that is then frozen and is optimized for accessing those elements. Now, we're going to jump over to Visual Studio, and we're going to talk a little bit about serialization using System.Text.Json. They've added support for working with required members and init-only properties. They've done improvements to inheritance. In .NET 7, they introduced support for inheritance in System.Text.Json and continuously improve that with .NET 8. I'm going to show you a couple of interesting things when working with System.Text.Json. So we're inside Visual Studio, and the first thing that I'm going to show you here is that I've set up a JSON, or defined some JSON here using a raw string literal. It's a nice thing or feature in Visual Studio as well that it actually highlights the syntax in the JSON that I've defined inside this raw string literal using the 3 double quotes. Beside the point, that's an older feature. Now, I'm setting my username here, and I have a collection of phone numbers. I'm going to deserialize this into a type called user. If I go into my user, not into that one, let's go back. If we go into the user, you can see here that the username is required. It's an init-only auto property that says this simply defines that you have to set this when you create an instance, and once you've set it, you cannot change it. So either you set it using the object initializer, and once you've done that, you can't change it. Now, for the second one, it's a little bit more interesting. If you look at the list of phone numbers, this here is in fact being set to an instance. It's a read-only property, right? So it's exposing an iList or a list of strings, but you can't change that once you've set it to an instance. So how come I would then be able to populate this with elements? If I run my application, again, that's the wrong key. If I run this, it's going to say numbers for Filip and actually print out the number that I have. So at the bottom here, I'm saying the username is my name, and then I'm iterating through all the phone numbers. So it did actually populate this list with some information. And this is all done by having this, decorating this with an attribute called JSON object creation handling. What this does is it allows me to populate this list with elements from the JSON. So it parses the JSON data and sees that here's a read-only property. I can now populate this with elements. When experimenting with this prior to the release of .NET 8, about 2 weeks before, I found a bug. So when you add a constructor to the type, let's say that I'm going to add just a property here. This here is using the primary constructor on my record. If I do this, it's not going to work. You can't have a primary constructor and also use this JSON object creation handling. So finding this 2 weeks before .NET 8, I reported the bug to Microsoft, and the alternative was either we throw an exception telling you that this is unsupported, or we have to rewrite the entire parser for JSON. Obviously, 2 weeks before, like if it was me, I would rewrite everything. But then again, I don't work for Microsoft, so probably a reason. So now if I run this again, it's going to throw an exception. Having support for required members means that if I don't set that in my JSON document, it's going to throw an exception. So let me show you that. If I remove my username from the JSON, if I rerun the application, that's going to blow up because it has to set that. It's probably because I'm running this already. Let's stop that. Look at that. It's thrown an exception telling me that I'm not setting this required property. All right. So that's a very good change to System.Text.Json. Again, making it more complete. The next thing they've introduced is some extension methods for HTTP client, called extensions for the iasync enumerable. What this is doing here is I'm setting up a URL that I want to fetch from the website, or the website I want to fetch data from. I'm setting up an HTTP client, and then I'm saying from this client, I'm going to get JSON data. You're going to parse that as an IEnumerable or an enumerable as a stock price, meaning that it's going to feed me elements into my system. What's interesting, though, that if I were to execute this endpoint, it would just give me a flat list or an array of elements. So what happens is that this internally does quite a few interesting things. First, it starts off a stream to my website, or the API in this case here. It tries to buffer load some data, it feeds that into the JSON serializer, and then I can use this async enumerable to consume that data as it becomes available. It doesn't make the entire, it doesn't fetch one element at a time from a flat list of elements, but it's using streams internally to avoid extra allocations, meaning that if it's a really large response, it could cancel in the middle and you'd still be able to process a couple of those different elements. And being an async enumerable means that I can use await for each to consume them very nicely in the application. I don't have to fetch the entire response as a string in memory. Traditionally you'd do read all the content as string, store that in a temporary string in memory, and then you parse that into a JSON data, and then you iterate over that. Extra allocations, completely unnecessary. If we have a stream open to the web server, let's just feed that into the JSON serializer. And it does that internally. Now, also I said that they've done some changes to the polymorphic or inheritance. You can now have inheritance in JSON. That support was added in .NET 7. So you could say, for example, that I have this record of a user which has a couple of subclasses. You can decorate JSON-derived type on your classes or your records to say that this has a couple of subclasses. The change they've done in .NET 8 is to also support interfaces. If your types were to inherit from a certain interface, you could deserialize into that, which didn't work in .NET 7. So while they're not trying to be feature, on par with the feature with Newton stuff.json, it's still a very viable serializer, and it's very performant. And if you own both ends, like the API and the application, this is a perfect match. All right. So the next thing I want to talk about is the time abstraction, which is also a new thing added in .NET 8. I've had an issue writing tests for code that uses dates and times. I know quite a bit about dates and times. I have a whole course on the subject, but writing tests for it and getting developers to use something that's not a part of .NET when it comes to working with dates and times can sometimes be a little bit tricky. So I worked in a company that delivered an app for public transport. So back in Sweden where I live, you can go on the bus and you buy a ticket for the bus using this app that I built. And we had an issue that when the clock turns over to daylight savings, your ticket would immediately expire, which is problematic. It only happens twice a year, though, or actually once a year, when it moves to the incorrect side of your expiry date on that ticket. And I mean, we change the clock at 2 a.m. at night. If that happens to be on a Saturday when people have gone to the pub, then it might be a little bit of an issue, but that, happens every 7 or so years. So we ignored it, which is the best way to solve time bugs. If it just happens, rarely, let's not care about it. So I guess the problem is that even though I'm following some of the best practices in this code block here, I'm using date-time offset because that's the best thing to use, but I've coupled myself to this. It's really difficult to write a test for this. And of course, I could abstract this. I could have a class on my own that I build that wraps date-time offset. I could have injected an interface or an action. I could have used node-a-time. There's endless possibilities. But if it's not a part of .NET by default, a lot of developers tend to just skip it, especially when it comes to date times. Like pulling in packages for JSON and everything else, like that, no problem. But when it comes to dates and times, there's something that makes it more difficult. So in .NET 8, they've introduced support for something called a TimeProvider. So instead of calling datetime offset.utc now, let's say that I want to inject something into my constructor. I'm going to inject something called a TimeProvider. Actually, we're going to do some proper naming as well. I'm going to store this in a local field. And then I can use this instead of doing datetime offset.utc now. I can call TimeProvider.getUTC now. And the benefit here is that now I'm no longer coupled to exactly the implementation of that static date-time offset class. The TimeProvider is an abstract class, which means that I can inherit from this and create my own implementation. I can create a fake implementation. And everything on this is also virtual. So I could override what happens when we call getUTC-now. By default, the implementation is simply using datetime offset, but we don't have to. So we could, for example, create a custom time provider that implements or inherits from TimeProvider, where I simply return datetime_offset.utc_now or datetime_offset.now. Probably don't want to do that. That doesn't make a lot of sense. But what we can do is that we can use a type called a fake time provider that comes with this new package or this new functionality in .NET 8. The fake time provider allows me to say that every time you call get UTC now, it's going to automatically advance a certain amount of time. It's a really cool thing. By default, it doesn't do that at all. So every time you call get UTC now, it will give you the same date. But I could, for instance, say that the start time is going to be 2 a.m. at the night where we're going to change to daylight savings. And then the next time you call it, it's going to advance by half an hour, because this here takes a time span. So I could do 1 second, 1 hour, 30 minutes. Makes it super easy to write tests for this. I could also, of course, say that, well, I'm going to use this system time provider, so I don't have to pass in a custom implementation, don't have to use my own provider if I don't want to. This here is the target type new expression introduced in C#10. All right, so that's the time provider. Makes it easier to write tests for, at least for dates and times. We should all use this. I've been longing for that feature, and I think it's a great addition. The next thing is that they've improved how to work with random data. There's helpers for randomness. So we can do random.shared, and that gives us an instance of a random class with a proper seed. We don't have to create our own static random anymore and pass a proper seed to get true randomness. Now, I'm not a security expert, so I'm not going to say that this here is cryptographically secure random data, but it's good enough for my use cases. And what I can do here, this is an example. I'm saying I have this array of elements. Give me 3 random elements. I could also pass an array to say shuffle this. It will give me a new instance with the shuffled data. I could say give me the next byte or next decimal or next integer in a certain range as well. Use this just as you would use with a random class. Just a little bit better. Next up, we have ASP.NET Core, which has also gotten a lot of updates. Now, Blazor is a part of everything that's been updated in ASP.NET Core. We're not going to spend, I have one slide where I'm just mentioning something about Blazor, but talking about Blazor right now it's like in a middle ground of, in .NET 7, it worked a certain way, now they've changed everything, and by .NET 9 comes out, they're going to change it again. So next year, if I'm allowed to come back, I can have more slides on Blazor. But right now, it's a great way to do full stack web development, but expect that it's going to change quite a bit going forward. So the changes with ASP.NET Core in general is that they now have support for HTTP 3, again, performance improvements as well. .NET 7 introduced rate limiting and output caching support. There's a lot that's happening internally as well. Support for metrics and complex binding, and quite a lot of great things. So again, let's jump over to Visual Studio. I have a project that's using ASP.NET Core. And the first thing that I want to show you is a new concept called a keyed service. A keyed service is a way for me to register the same interface multiple times with my services collection. So I can say that I have an iCache. If you ask for that, I'm going to give you an in-memory cache. But if you happen to say that you'd like to get a distributed cache if that's available, I've added a named one or a keyed service to say that, hey, I'd like to get the distributed cache. If it's not available, or if you pass something else, that's fine as well. It's just to indicate to the service provider, service collection, that you'd like to get something if that's available. So I can use this inside, for example, I have a map get here. This here is a top-level statement using minimal APIs, which is the new thing to build really small services using ASP.NET Core. Simply mapping the root of my application to return some data. I have this injected thing here. So every property that you add to a map get, if that doesn't come in from the request, the service collection will try to pass that instance for you. In this case, I'm saying I want an iCache. Preferably, I'd like to get the keyed service memory, or I'd like to get distributed. And if you misspell that, you might have a problem. It might always give you the default one. So this here is a good alternative to allow you to choose what you want. Because previously to this, you had to write an extra interface to register the same thing, or sometimes you had a little bit of a problem. It was a bit random. Next thing, I mentioned this quite briefly. They added rate limiting in .NET 7. If you haven't seen this, you can simply append rate limiting to your minimal APIs to say that I want this to be rate limited. Now, this is a per service, right? So if I say you're only allowed to call this endpoint once every second, and you can queue one request for a fixed window, then that would only be viable for this instance. If you have a distributed system, that would be per service, right? Ideally, you'd have rate limiting on a load balancer, but in this case here, if you have a very small service, you might be running your thing in your basement, then this is a good addition. They've also improved on the debugging experience. So let me show you, actually before I do that, let's scroll down a little bit here and talk about one more thing before I show you the debugger experience. There's a concept called short-circuiting routes. So imagine that I have a huge amount of middlewares registered that my request has to go through, and I want to add a robots.txt or add an endpoint that just returns some static data. It's quite unnecessary that I have to go through all the middlewares in the entire pipeline. That way, you can skip by it by just short-circuiting to say, I want to execute immediately. By adding .short-circuit to your endpoints, it's going to skip all the middlewares, all the cores, all the authentication, all of that. Next up, they've done support for complex bindings and support for the anti-forgery token. So in this case here, I have a map get again where I expect an anti-forgery to be passed into this action. I can create an anti-forgery token, and I can add this to my form, and then I can say that I want to post this into another action. Again, I'm using the raw string literals to code my HTML inline here. Starting to feel like PHP, like I did 25 years ago. Again, sorry. All right, should probably have this in a separate file. Anyways, so the consumer side of things, of that post that gets this passed into it, I have a map post called upload that accepts an iForm file. So this complex binding allows me to get a form file passed into this action, as well as the anti-forgery. Obviously, we have to validate the request for that anti-forgery, otherwise you're going to have a problem. That's outside of scope of this talk here, but just want to mention it. If I run this with a debugger attached, and I'm going to post a file into this endpoint and just show you the debugger experience. It's quite a subtle change they've done to make it better. But if we hover the context, hopefully this is big enough for you all to see, everything here is a little bit better than it used to be. They've added information right here when I just expand the context. Previously, you had to drill down into all of these different properties to get more information. A little thing that just reduces the amount of time that I have to spend to find my information. All right, so that's the changes in ASP.NET. Together with all the performance improvements internally in .NET, they've also done that same type of work in internals of ASP.NET Core to make it even faster and use less allocations. So to be honest, minimal APIs is probably the way going forward if you want to build small services in a microservice architecture. I still do MVC projects for really large enterprise projects where you still have to use MVC. But for smaller things where I have a backend for an app, for example, I try to build minimal APIs. All right, so to summarize that, we saw these short-circuit routes, which executes immediately, bypasses that entire request pipeline. Keyed services allows me to say, hey, I want to get a specific service if that's available. You're also allowed to pass in whatever you want. This is a nice addition. I really like this. And of course, the complex bindings allows us to pass in really complex things like a form file. Now, I did promise that I was going to mention Blazor. I don't have a demo for Blazor, but it is with .NET 8, it is a full stack web UI experience. It's now really the thing that you want to use if you're building full stack web development on .NET, at least for the web, right? But it may change with the next version of .NET as well. So I'm going to add a little bit of a note there saying that this could actually change quite a bit. It's still quite new. They're still doing a lot of work on Blazor, but it's a very interesting time to be a .NET developer if you're doing full stack web UI. Speaking of UI, they have also done a lot of work on MAUI. Anyone here building mobile apps on .NET? No one. Oh, wow. Oh, wow. All right, bye. I'm kidding. I do understand why. Again, sorry to anyone from Microsoft here. So with .NET 6, they didn't really make the deadline. So .NET MAUI is the cross-platform mobile experience for .NET. It's really Xamarin where they've done a lot of improvements to it. With .NET 6, they kind of missed the deadline to get it released. They weren't really done. With .NET 7, they pretty much forced it out. They made it GA. It worked, but being .NET 7, which now ends support in May this year, no one really wants to jump on for a short-term support version to move their entire app if they have one. So with .NET 8, it becomes a little bit more of an important release. So really, a more fair comparison would probably be that in .NET 7, the picture wasn't really complete with .NET MAUI. But now with .NET 8, the idea is that everything is just going to work and be very nice. There's a lot of problems, but they're going to work on that and fix all the small issues that keep arising. But to be honest, comparing the experience of building a mobile app right now to what it used to be 4 or 5 years ago, the experience is actually getting very good. And it works quite well. The idea is, of course, that we build one application and target all the different platforms. It often works very well, unless you have to use very specific stuff for this specific platform. Now, we have our app code, we have a layer of .NET MAUI, it targets different, like iOS, Android, and so forth, and you can build this on all the different .NET pieces. And again, being built on .NET 8, internally, it makes use of all the improvements to AOT, to all the performance improvements, using all of those different smart things internally. All right, so we're not going to spend more time talking about .NET MAUI, since no one in here is doing mobile. Let's talk about C#12 instead. C#12 introduces quite a lot of small features, but that are going to change how we build our applications. And traditionally with C#, I've done what's new in C# talks for the past many years. And it's interesting because every year they keep adding more and more and more and more. And if you compare C# today with what it used to be with C#2 or 3 or 4, for example, it's very different. But it changes with the times and with the types of applications that we build. I mean, when C#1 came out, there was no reason for async and await. The idea around even using async and await and building mobile apps using C# was really out of the question. Back then, we still used Symbian OS and built C++ applications. So with that being said, there's so much in C#, it can be quite hard to follow along with all the features that have been added. C#7 introduced pattern matching, and a lot of more patterns came in C#8, 9, and 10, and 11. Fortunately enough, we don't have more patterns to cover now. Maybe the next version of C# will have more patterns added to it. So let's actually look at what's new in C#12. There's something called a primary constructor. I briefly showed you this on the record type. It's very different, though, if we look at primary constructors on records, or very different from the primary constructors on a class. The record has the primary constructors, if you define a property on that, it actually creates a backing field, it creates a publicly exposed property, it gives you value-based equality, and gives you a whole lot of things. If you use primary constructors on a class that looks very similar to on the record, all it does is create a backing field in the constructor. It doesn't create anything that publicly exposes that. That's both good and bad. If you know why, it's probably good. I don't think that I would like all my private fields to be exposed publicly, at least not if I'm doing good design. We're going to take a look at that in just a second. Now, they also introduced collection expressions. I've showed this quite a few times now, but I haven't really highlighted that this is a C#12 feature. This, together what's known as a spread operator, is supposed to make it easier to work with collections of data. There's also something called an interceptor, which is a way to replace code when you're compiling your application. It can be quite dangerous. I'm going to show an example of that as well. There's optional parameters in lambdas, alias anytype, inline arrays, ref read-only parameters, and an attribute to define that you're building something that's experimental. So you have to go into your application and say, hey, I want to enable experimental features so that you can internally build things that will give you a compiler warning if someone's using something that you determine to be experimental. Don't use this for everything you build. That's going to make coworkers angry. All right, so let's jump over to Visual Studio and look at C#12. So the first thing that I want to look at is the collection expressions and the spread operator. Here we go. So this here is a new syntax. I don't have to new up a new array. I don't have to use an object or a collection initializer. This, in comparison to what the amount of code that you had to write before, it's fewer characters, right? But it's actually doing a lot more than just that. I'm saying that I want this to be a list of a byte, but the collection expression is, in fact, smart enough to look at the left-hand side of my equal sign as well. So I could change this to be a byte array instead, and it would still work. So I could change this to pretty much anything that's related to what I have on the right-hand side. I could say that, well, how about I want this as a span of byte? And then this would be that performant type pointing to that arbitrary amount of memory. So this is a very nice addition, and you can even use this to then combine multiple different types of arrays and create a new one. So let's just revert this back to make it a little bit more interesting. I have this list of bytes here that I'm initializing with my 4 bytes. I then want to say, hey, I want to calculate a checksum for this data. I've just made up some checksum data here at the end. Normally, you get them in 2 separate pieces, right? I'd like to combine them in one array. There are multiple different ways to do this. But with C#12, we get this spread operator, which looks very much like a range. But a dot dot followed by the array will take this entire array here and pretty much just put it in here. Super smart. And do the same thing for the rest as well. And as you see here, we can even use the spread operator and combine it with actually defining the elements. So it's pretty much doing this. But this syntax here is a little bit more concise, and it doesn't require me to repeat myself. And what I'm doing here is that I'm, in fact, now combining a list of bytes as well as a byte array. They're two totally different things, right? The list I can add elements to. The byte array I cannot, obviously. But I'm saying that, hey, I want this to be a span of a byte, which means that it's this super performant type, which underlying array or structure or whatever it's using internally to represent this data, it doesn't matter really, as long as I know that this is really performant to work with. I could also, if I wanted to, say that, well, combine these two and put them into a list of a byte, making it possible for me to add more elements. Or just use a normal byte array. So again, the collection expressions is really powerful and allows us to kind of configure exactly how we want that to be represented. All right, so the next thing that they've added is primary constructors, or support for primary constructors. So I have a class called user. I guess, would it make sense if I used a primary constructor on my user to say, hey, I require a constructor that accepts the username? I would probably say that I would prefer this to include, or use a record instead, because it's a DTO or a data class. So I would very much say that, hey, this is a record instead, which would make this very different. I can't even spell a record. If I say, hey, I want a record, and I want that to be a username, and you can only set it once, like I've reduced the amount of code that I had to write, but I also got the benefit of this being using value-based equality, which means that if I have 2 instances of this user and compare them to each other, it's going to compare the username's values instead of the references. And that doesn't work with any framework, so you'd have to go back to use a normal DTO. But for anything else, like that you're exposing over a domain object or something that you're exposing over the web, this makes a lot of sense. I'm going to revert that just to compare it with what I actually think this is viable for, and actually how you could use that private field. So internally, this just creates a constructor that sets a private field. If you want to use that anywhere inside your class, you'd have to then actually access it. Where it makes sense to use this is probably for classes like an order controller, where I can now remove the constructor from my controller class. Like if you're doing MVC, for example, I do that quite a lot, and I say, hey, I want these 15 interfaces injected into my controller. I know that's probably not the best practice, but I like to tightly couple my controllers to everything in the application, so it does everything. Then I can at least reduce the amount of code that I write in my class. So I can say that, hey, this here, once an IUse repository injected to it, it's going to store this as a private field in my class. And we can then access it anywhere inside any methods inside this application. If you haven't seen this before, this here is in fact returning multiple values from the same method. It's using a tuple or a tuple or whatever you want to call it. It was in C#7. Just a fancy way of skipping having to introduce a separate structure or class to return this data. And in here, I can access that repository. It's not going to be publicly exposed or anything like that. So a little bit of a nice way to reduce the amount of code. I also now want to show you the last thing of C#12 that's quite an interesting language feature, to be honest. Now, there's this concept of an interceptor. An interceptor allows me to intercept code, kind of obvious by its naming, right? I've created a class called a logger. The logger itself doesn't do a lot. It has a method called log. On line 7, it calls log internal. If I press F12, we can see that it's going to throw an exception, right? Super simple. And then I call logger.log with some text. This will call this method and then throw an exception. If we run this with the debugger attached, anyone think this is going to throw an exception? It would be so funny if that was a trick question and if it actually threw an exception. Let's see what happens. I'm going to step into the logger. And we can see here that it's actually going to try and call log internal, but if I try to step into that, it actually just steps over it. It didn't do anything. And if I rerun the application without the debugger attached, we can see that it actually prints hello world to my console. So what's going on here? What's actually happening in the application? Well, let me show you. I've introduced a separate class. Actually, if I do logger dot, you can see that there's I'm going to try and zoom in here. There's a debug log, which is an extension method on the logger itself. So where is that coming from? The logger doesn't have that on its own, right? So that has to be defined somewhere else. Extension methods have been around for a very long time. I've introduced a file called Interceptor.cs. This here is defining an extension method for that particular code piece that I want to replace. I'm then saying I'm going to intercept whatever is inside this code file on line 7, right? On line 7, which is this call here, I'm going to replace this code with this call to this method instead. And then what I also did, I added the attribute debugger hidden. This is the best prank to pull on a coworker. I love it. You can actually see that says external code inside the stack trace, but it gets so hard to actually figure out what's going on. It's a lot of fun. So what actually happens here is that it calls this extension method. Obviously, you have to know the exact line in the file, as well as which character it starts at, for it to know what to replace. So why would this be useful? Well, imagine pulling down a NuGet package that has a source generator that will generate source for your application. It can inspect your current code by looking at the code structure. It has access to all your files. It can then create one of these interceptors when you compile your application to replace that. Very much like IL weaving. To use Fody, for example, to replace code that makes your application more performant. This is used quite heavily internally. ASP.NET Core uses this, especially when you're using ahead-of-time compilation, to generate faster code for your specific actions. So it is quite useful, but I use it to prank my coworkers, which is quite fun. I mean, you wouldn't write this yourself. If you have access to the code base, I mean, go in and change the code, because this has to be a part of the actual compilation. So, but it is great for source generation, which is a quite complex topic on its own. But it's used a lot with ahead-of-time compilation. So with that being said, that's kind of the things inside C#12. And I do reckon that the most useful thing that you're going to see a lot is the collection expressions. This is something that's going to change how you access your elements, how you work with arrays of data. And together with using this span, this is going to make anything working with arrays and collections of data a lot more performant. I will say, though, because this is something that's quite confusing, the span itself, while it's been around for a while, is anyone here using spans regularly? Okay, a handful. it can be quite tricky to find a use case for this. Everywhere where you use a span, it has to be in a context where you're not using async await, you can't use it with yield, and there's a couple of more places where you can't use this because it's using the stack to be very performant, which means that when you leave the stack frame, all the data is going to be lost. So that's why you can't use this with the async and await. There's also a thing called a memory of t, which is going to, not that memory, there's memory of t as well. You'd have to then write a little bit more code to convert that span into the memory of t, but it's working quite similarly, except it's stored on the heap. You have to move it back to the stack to do all the performant operations, but at least you have a similar structure to work with it. So if you find yourself wanting to use a span and that doesn't work, see if you can use the memory of t instead. Again, this is something that you use quite heavily inside the .NET framework, or .NET, sorry. I would also suggest, like, if you want to learn more about all of this, all of the performance improvements, there's Steven Taub on Microsoft. He writes a blog post every year when they release the new versions of .NET. I'm not really going to call it a blog post because you need 2 weeks vacation to read through it. It's like 450 pages long. But that just shows how much goes into making .NET more performant with every release. There's performance comparisons on how to make it better and why it's faster, allocation-wise, why it's better, and also, of course, making the debugger experience a lot better. To summarize exactly what's going on here, we have the collection expressions that are going to make it a little bit different working with this. We can use this with the span, the arrays, the lists. One thing that I'm going to say here is that while that looks like it's using the range to slice up the syntax, the spread operator is different. If you'd like to say, I only want to get a little piece of the payload, you'd have to do that first, to slice it off, and then say that that is what you want to spread onto your array. Hopefully that makes sense. And then, of course, for the primary constructors, we want to use that for classes where it makes sense. I would use it for an order controller, for example, instead of using it for a normal DTO or something stored in my database. Because if I take this primary constructor on my user here, which takes a name and as well as the datetime offset, also notice how I'm using lowercase here to indicate that this is actually a private field. I'm not going to prefix my private fields with an underscore. So let's stop doing Hungarian notation. But this here is, in fact, a private field. And I can see that by looking at what's decompiled. So it actually introduced this backing field. It introduced a constructor. And while it does provide me with a nice toString implementation as well, this is quite limiting. I would prefer to rather use a record type for my data objects. They also introduced this optional parameters in the Lambda expressions, which is quite useful if you're doing minimal APIs. I use this in the minimal API that I used earlier, which means that with the primary or the default parameter or optional parameters in my Lambda, I can call this Lambda without actually having to specify that, just like any optional parameters on any method. They're also introducing something called alias any type. So I could say that I want to say I have a point, and that is this tuple or tuple. I don't then have to repeat myself all over the place, which is quite handy. It's all really about reducing the amount of code that we have to write, get the compiler to figure things out for us, and generate as much code as possible. My goal is to write better code that runs faster and has less bugs in it. So far, C# and .NET makes it a little bit easier. And finally, they're introducing the interceptors, which is heavily used within source generators, and simply you point to the method that you want to intercept. It doesn't, you have to say the exact path to the file, but again, a source generator or something that runs as a part of the compilation can easily figure this out. Now, I'm also going to say this, that the interceptors, you have to opt in to using the interceptors. So if you're pulling down a NuGet package, for example, it can't just blindly intercept all of your operations, because that would be dangerous. So you have to say exactly or explicitly define which namespaces are allowed to replace my code. This is heavily used internally in ASP.NET Core. So they're doing this to, again, improve performance. The request delegate generator uses this, and we're probably going to see a lot more internally using all of the features of C# 12 and 11 and 10 to make things run faster and have optimized code paths, less allocations, and all of that. So I guess what's next? In C#, there's this language features status page. I think they've just announced one feature so far of what's coming in C# 13. But knowing Microsoft, let's not yet talk about what's coming in C# 13 because it's going to change a lot until November when they release that. As I mentioned earlier as well, there's some discussions on how to improve the internals of async and await in .NET itself, in the core library. You can follow that on GitHub. It's a really interesting discussion on how to make threads better, how to do context switching faster, and really how to, again, optimize the performance of the applications. Even though that we can optimize by doing ahead-of-time compilation, and we can use all of these tricks to be more memory efficient, it's not really as fast as a C++ application optimized for a particular architecture, but it's really good enough for most use cases. If you have a web application with millions of requests, a lot of these performance improvements, especially allocation-wise, will make hopefully running the application cheaper. As you need less memory, it's going to be faster, you'll need less CPU power, and so forth. Makes it easier to scale the applications. So really, they're doing heavily work on all of the internals of both C# and .NET. If you like to listen to me, I have about 25 courses on Pluralsight, covering a lot about C# and .NET in general. And again, if you have any questions, I'm happy to get emails sent to me afterwards. I always like talking about what's coming in C#, what's new in the language itself, how .NET keeps evolving. There's so much happening in that space, and it can be quite tricky to keep up. I know by myself, I spend most of my time trying to keep up with what happens in .NET, what happens with C#, where is the language going? And I said this earlier, that if you are coming into C# and .NET and haven't been around for a long time, it can be a little bit puzzling knowing exactly where do my old knowledge fit into this newer style of application. Has anyone been out of the game for a while and this is the first version of C# that you see in 2 years? Yeah, a couple? Yeah, so this is probably, a few of these things are probably very confusing, and that's totally fine. And I'm not saying that everyone should now go back to their office and refactor their entire applications to use C# 12 and just update to .NET 8. If it's possible that you can just change your minimal APIs or whatever type of application you're using to use the newest version, that's great. But don't do it blindly. Don't just rewrite your applications to use the latest stuff. That's rarely a good idea. If Visual Studio hints you that this can be optimized, you can write less code by using this new language feature, by all means, refactor that code piece. But again, just like when they introduced nullable reference types, don't just enable things and just go on vacation and hope that it works when you get back. There should be a little bit more thought going into it. While these will help us write less code and more performant code, it should, with anything, be used with caution, right? We should exactly know where we want this to be used in our applications. I hope you found this useful. There's a lot happening in .NET and C#. This has been a roller coaster of a ride, going through all of the features, all of the stuff that's been added to it. And I hope to see you again next year. Thank you so much for coming. On the way out, please remember to vote. If you like this, put a green thing in the box. If you didn't like it, there's an exit over there without a box. I'm kidding. Thank you so much.